Hello YouTube, welcome back to the channel guys. So in today's video, we're going to continue with our series of introduction to large language models and fine tuning. So in this video, we're going to be looking at basically techniques to reduce model hallucinations. So in the last video, we went about what are LLMs from a very non-technical point of view and a bit of technicality. In this video, we're going to be looking at, and in that video, we talked about hallucination as the last topic, or the last concept that we covered in that video was about hallucination. In this video, we're going to talk about techniques that are there to help you reduce hallucination within your LLM applications. Okay, so look at some of these techniques. Also look at and then see how also fine tuning can come in to help reduce hallucination in certain cases as well. So let's get started with it. So this whole course is all about introduction to large language models and how to fine tune large language models to do different specific tasks, right? So you're going to be looking at the challenges that LLMs are facing, ways around these challenges. We'll look at different ways such as prompt engineering, challenges with prompt engineering, retrieval augmented generation, fine tuning, the real world uses of fine tuning, comparing and contrasting fine tuning versus RAG, and all the other stuff, right? So if whether you should combine fine tuning with RAG or you should use only one of those, right, instead of combining them. So we'll take a look at all of those to understand these concepts in detail. So let's get into it. So let's first look at the challenges that LLMs face. So the challenges that LLMs face. So let's look at some of the limitations of LLMs, basically the challenges or the limitations of these LLMs, right? So one of the things is that they do not have up-to-date information. So back in the days when ChatGPT came out, right? If you ask it what happened today, it can't really tell you. It tells you my knowledge is limited to, I think, say 2020 or something like that. Yeah, and that is because LLMs are trained on some data. That data is the source of their knowledge. So when you're asking a recent question on about something that they have not been trained on, or some information that is not part of their training data, they lack the ability to answer this question because they simply don't know, right? So you need to find a way to fine tune these models to be able to answer such questions, right? And this is just one of the limitations of this. So we'll talk about the different ways you can go around doing this. I think I'm going a bit ahead of myself, but basically, uh, LLMs cannot have the latest up-to-date information without using any kind of tools or any other techniques, right? And we'll look at all these tools and techniques later on. But a bare large language model cannot give you the most relevant and up-to-date information that is not within its training data, right? So if you go and ask what happened today and the LLM does not have data about today that it was trained on, then it can answer that question, right? As we saw at the beginning stages of ChatGPT. And then also, let's move on to the second, which is LLMs can be very general. So LLMs are trained on general information from the internet, right? So we saw this in the last video where we talk about pre-trained model, where they're trained about, they're trained on data from the internet, right? So they're trained on a bunch of data from the internet, and this is just a lot of general information. So if you are having a company and you're trying to build chatbots or chat systems, and in this case the chatbots need to be very domain specific, then you find out that they're struggling to answer some questions because they don't have that domain specific knowledge. So how do we overcome this? What are some of the ways we can overcome this? Right. So ways around these challenges that these LLMs face. So let's look at some of these ways that we can overcome these challenges that LLMs face. So to understand this, I'm going to be using basically an illustration to demonstrate, to explain this to you, right? Because for me, I really like a real world examples to explain some concept instead of just being so theoretical about everything, right? So let's use some real world examples, something that you can relate to. So imagine that you work for a company that deals with e-commerce products, right? Maybe Amazon or eBay or something like that. And you are an AI engineer working for that company, and you have been tasked by your boss or your lead to build a chatbot that customers can interact with to find details about their products and their services that the company offers. Okay, so now put yourself in the shoe of John. All right, so we have John right here, and John now is being instructed by Helen, who is his boss in this case. So now John has been tasked to build a chatbot that customer, basically more like a customer support service, right? Chatbot. So now put yourself in the shoes of John. How would you go about doing this? Okay, just take a moment, think about it. How would you go about doing this? So all the knowledge that you have covered so far, from the first video. I know this is still early, but just think about it, right? Maybe you come up with some genius idea that will change everything that you are currently having today. So just pause the video and just think about it, right? Just don't do any Google research. Just think about it by yourself. Okay. Okay. So I'm gonna move on. So one of the techniques that we currently have and people are currently using, and if you're building an LLM system, one of the things that you fundamentally start with, like the first starting step, is prompt engineering. So what is prompt engineering? It sounds like a very fancy word, but it's actually very simple. So prompt engineering is all about learning how to communicate with these LLMs such that you get them to do exactly what you want them to do, right? You structure your text, like the text that you type into ChatGPT. You structure it in a way that the LLMs understands exactly what you want to do and is able to provide you the output that you want to do, right? Basically, effective communication with LLMs. That's basically what prompt engineering is all about. Structuring your prompts in such a way that you get LLMs to do exactly what you want them to do, or to output the desired output that you're looking for. That's more or less of prompt engineering. It's more of a fancy word, but anyway, let's move on. So one of the things that if you start building a chatbot, personally, one of the things I start with is this prompt engineering. So there's no like one size fits all. And it's one of the challenges I face working with people. Sometimes it's like they think there's a one size fits all, there is a one ultimate solution and everything else is BS. And that's not really the case, right? There's no one size fits all solution. Just have your use case, try different stuff and see what sticks, right? And then improve on that. So in this case, you have a system prompt. So this is basically what you would type into ChatGPT. But now in AI, if you go in deep into the technical aspect, you have system prompts, you have user prompts, and you have all those kind of things, right? So system prompt basically tells the LLM how to behave. So in this case, you're telling it, your name is Helen, you're a customer support agent working for Coded Prince LLP. Okay, that's my future company. So users will ask you a variety of questions regarding our services. You should respond in a friendly and welcoming tone. For example, the user asks, "Hello there." This should be your response. "Hello there, how can I help you today? My name is Helen. You mind introducing yourself?" Right. So that's basically how we are telling that, basically prompting this our chatbot to behave. His name is Helen, or her name is Helen. Uh, she works for Coded Prince LLP, and he should be very friendly to use. She should be very friendly to users in a friendly tone. And this we thought it basically give it an example of, if the user says this is how you might respond, right? So that's basically it. And then we give it the user's question, which will be passed in. So user query will be passed in at runtime, and then that will go into the system prompt, and then the AI can then respond to this. So that's basically a prompting, right? Okay. So now let's move on to something that we call, okay, we'll look at in context learning just in a moment. So there are different types of promptings. One of the things is just single shot prompting, few shot prompting, zero. Okay, yeah, look at those. The other types of prompting techniques out there, chain of thought reasoning, and all those kind of things. So basically, in the above example, we just gave it a single shot prompt. Why did we call it a single shot prompt? The reason why we call it a single short prompt is because we give it an example. In this case, we give it only one example. The user says, "Hello there." Your response is, "Hello, how can I help you today? My name is Helen. You mind introducing yourself?" So that is just a single short prompt because we give it a single example on how to behave or how to respond to users. So that is called a single short prompting. We also have few short prompting, whereby you give the agent or the AI system more than one example of how to respond to users, right? Or how to interact with users, or how the conversation flow should be handled. That is called few short prompting. So they have single short prompting, few short prompting, right? So you can give the model some background knowledge as well, or some expert information on how to behave. So this, we call this one in context learning, and I'll show you, we'll go over this just in a second. So let's take a look at what is really in context learning. So in context learning, basically we give some knowledge or domain knowledge to the agent within the system prompt, or within the prompt that we are sending to it. So in this case, we want, let's say that we have Helen again as our agent name, and this agent is working for or this AI system is a chatbot that is being working for me for an investment firm or something like that. And this investment firm needs to do some calculations when the user asks it a bunch of questions. So in this case, you're trying to calculate the earning per share or the price to earnings, right? The PE or the PS. So we want specifically to provide the formulas to calculate the PE or the PES within our prompt, such that the agent learns how to do this from the examples that we give it within our prompt. So we have already the context there. That's the context. So in context learning. So it's learning with from the context. So we have provided the context in finance, and in the financial analysis, the price to earning ratio is calculated by dividing a company's current stock price by its per share as a PS. So it's earning per share. A high PE ratio typically suggests investors expect high growth, while a low PE might indicate the stock is undervalued or the company is struggling. Generally, a PE ratio is between basically 15 to 25 are considered reasonable for most industries. So I provide all this context in context learning to our agent through the prompt. That is in context learning, because the agent is learning from the context within the prompt, right? And in here, we've also provided an example. Basically, equation: Apple's trading stock is at $180 and has an EPS of 16. What does this tell us about the stock? And then the AI should go ahead and reason. Apple's PE ratio is 30, which is basically 180 divided by 6, which is above the typical 15 to 16 ratio. This suggests investors have a high growth expectation for Apple, or the stock might be overvalued compared to historical norms, right? So this is just a dummy example. I'm not saying this is what their thing is in the real world is. So how does this AI know all this information? It knows all this from the context that you provided it. That's the whole idea of in context learning or in context prompts. Oh, sorry, in context learning. I need to change that. It's not in context prompting. Okay, I think you can also say in context prompting, but mostly people use the word in context learning. So that's basically an example of in context learning. Okay, so I didn't go over what zero shot prompting is, and I didn't go over this because I want you guys to take this time. This will be a little assignment for this video. Just go ahead and try to figure out what is zero shot prompting. From the word, you can pretty much guess what it means. But anyway, I'm gonna leave that to you guys. Just push yourself and do some research on what zero shot prompting is. Okay, let us know in the comment section below what you think zero shot prompting is. Okay, now let's look at the pros and cons of prompting. So let's take a look at the first with the pros or the advantages. So it takes less infrastructure to set up. Like this, like writing this prompt is literally you can do it in minutes, right? And then iterate over time. So first approach to try out before anything else. That's an advantage of prompting. It's easy to do. The first thing you probably want to try out before trying to apply any other aggressive techniques. So if you try out prompt engineering and it's working fine, then voila, good for you. You don't have to go ahead and try other techniques and have sleepless nights, right? So you can just go ahead and have a good day. But the disadvantages of prompt engineering is that it's very iterative. It takes a lot of time. So sometimes you have to iterate over multiple prompts before you figure out one that really sticks, right? So it's time consuming sometimes, right? Yeah, and you can also use AI to help you prompt and do prompt engineering and brainstorm, right? So yeah, it takes time. Just take an initial prompt that comes from your head, write it out, see the weaknesses, find the ways around those weaknesses, and then include them in the prompt, and then iterate over and over again until you have something good and working. And you can use AI to help you, ChatGPT or Claude, to help you with this kind of testing. Okay. So once you have done that, let's move away and look at the challenges or the limitations of prompt engineering. So one of the challenges that we have is that, okay, so how might John, let's go back to John for a second. How might John use prompt engineering to solve the issue whereby he is working for an e-commerce company called Code with Prince LLP, and Code with Prince LLP has a lot of products that it sells or service that it offers, right? So what John might try to do is, okay, I'm just gonna get a list of all those and then put it within the context and apply in context learning, right? So I'm going to replace all the context here with the product information or the product catalog or the services catalog basically saying the product, its price, description, and stuff like that. I'm just gonna go ahead and dump all that within the prompt. Okay. So back in the days, that wouldn't work because of the limitations in what we call the context window. So the context window is basically the amount of text that an LLM can handle at a given time. So back in the days when LLM started, context windows were pretty much small. But nowadays we have context windows really huge. Example, Google Gemini has really huge context window. In fact, you can fit a whole book in there. So John might just think, you know what? I'm just gonna go ahead and get all the database and just pump everything in there in the let prompt engineering and context learning handle the stuff. Well, that might work and might not work in some cases. It's not the best approach. One, we have the one is okay. Let me start from the base. One is very expensive because the bigger your prompts are, the more you pay, right? Because you are being charged per token. So the each word counts, each word or sub of a word counts as a token. So the more words you have, the more tokens you are using, the more you pay to these AI companies that are providing to you the model. Basically, the model providers. The more you pay to them, the bigger your context window or your prompts, the more you pay to them. That's basically it. So you don't want to do that. That's a bad approach. Imagine having 10,000 products and trying to fit all of them within context window. So each chat with a user, you're passing all those 10,000 products within the context window and you're getting charged for that. That's not a scalable solution, right? Okay, moving on from just the pricing from the business point of view, and let's take a look at something else. Let's look at the another technical challenge that might come into play, which is lost in the middle. So lost in the middle, it refers to a phenomena observed in large language models through research, where information located in the middle of large contexts is often neglected or overlooked by the model, even if that information is crucial for the task at hand. So if you have you pass in your 10,000 product catalog or products database within the context or within the prompts and expect the model to just go and find the product and then answer the question based on that product, yeah, it might work in some cases, but LLM suffer from this thing called lost in the middle, whereby if you give them so much stuff, they forget things at the middle and sometimes at the end, right? And we'll look at why this is the case. Why does this happen? So from my research and Googling stuff online and trying to see why this happens, is that there are two main situations that I came across. There might be other ones, but I came across two main, and I'm just going to mention these two out. So the one is the bias towards the beginning and the end. LLMs tends to disproportionately focus on tokens at the start and sometimes at the end of of the input sequence. This is partly due to the way the attention mechanism works in large language models. So if you know that attention mechanism work, what is attention mechanism? Don't worry about it. You can always Google it if you have your free time. You can always learn about attention because LLMs came up with this the transform architecture and all this. Attention is all you need paper. You can read about all this. That's where we have all this beginning of all these great innovations in AI begin from my point of view. So they suffer from this thing called due to attention mechanism. They can which gives more attention to tokens at the beginning and sometimes at the end. So that's where LLMs might end up forgetting things within the middle, right? Which is called lost in the middle. So attention allocation, the softmax operation in attention layers often result in higher attention scores for initial tokens regardless of their actual relevance. So it gives more attention to more tokens at the beginning and ends up ignoring the ones at the middle and sometimes at the end, right? So that's one of the reasons why we have the lost in the middle. So that's why you don't want to pump. You don't want your prompts to be extremely huge, right? So you can sometimes can suffer from this limitation. And also, if you're sometimes also model providers, yeah, they also pass in their own system prompts in the background. Like recently, Anthropic, their system prompts leaked, and yeah, so it was really huge system prompt. So imagine that huge system prompt plus your product catalog of 1,000 products, right? That's gonna be a ton of issues. Okay, so now let's look at another technique. So if we have, let's say that John has tried prompting and prompting didn't really stick. So another technique that you might go ahead and use is retrieval augmented generation. So John abandoned the prompting approach because the context window will be just too large and the LLM might suffer from loss in the middle, which might result in poor responses from the AI. So retrieval augmented generation, which is another technique that he can try out. So what is retrieval augmented generation? So we have covered a bit of this, I believe, in the last video, if I'm not mistaken. But retrieval augmented generation is all about, let's say the user asks a question, right? Instead of passing your whole data, basically product catalog within the prompt, what you simply do, why don't you just filter and find the most relevant products that can be used to answer that question? So if the user is talking about smartphones, instead of passing in all the shoes and all the books and all the computers, why don't you just get smartphones and pass that into the system prompt? The prompt will be much shorter, less suffering from loss in the middle, hence you can have greater output, right, from the greater responses from the LLM. So that is now what we call retrieval augmented generation. So you go and retrieve only the relevant content, and then you combine it with your user query and your system prompt, and then from there you pass it into the LLM and then generate a final response based on that. So retrieve, search for relevant information, augment, add the user question with the relevant information, as well as your system prompt, and then pass it to the LLM and then have it generate for you a final answer. That's basically what's RAG stands for, or Retrieval Augmented Generation. So some people are saying that, oh, you know what, RAG has been last year, last year. Okay, RAG system was all over the place. Right now we have other techniques. We don't need RAG anymore. We have MCPs. But yeah, they're still being used. I mean, it's just like model context protocol, MCP, for what people are using right now, and say it's going to replacing RAG. It's just another technique of passing context to LLM. So I don't really see it as, it's more like a RAG to me, my point of view. Okay, let me not go into that in this video. Let's just proceed with it. So you can check out what MCP is if you are interested in that. That's also another technique you can use. So why does this happen? Why does this happen? So okay, we need to look at it. We have looked at why that happens. We actually need to change this text. It's actually advantage in the pros and cons of large of RAG, right? So one of the advantage of RAG systems is that we can deal with up to date information. So for example, let's say the price of a given product change. So all you have to do is to change the price of the product in the database. So if during runtime a user asks a question about that specific phone or mobile phone, and you retrieve that mobile phone, it will have the latest price, right? So you don't have to go ahead and fine tune the whole large language models with that latest information, because like prices of products are always changing. So in such a case, RAG is a good approach, right? So you can always update your database. Once you update your database, everything else will be updated, because the LLM will pull the retrieval, or RAG will pull from the database or vector store, and that will have the relevant information, and that relevant information will be used by the LLM to generate relevant and updated responses. So it beats that limitations of LLMs having outdated information, right? So chat systems that require very specific domain information, like in this case about our products, that's very specific and it's always updating. So in this case, a RAG is a good approach. So let's look at some of the disadvantages of having a RAG system. RAG, and one of the things that people say that RAG is the latency, right? Because if you ask a question, the agent first has to go ahead, query our knowledge base or our database, retrieve relevant information, pass that relevant information to LLM, and then generate a final response, right? That can take some bit of time. That's latency. Creating vector embeddings. So vector embeddings or vector stores basically can take time, and you are paying for these tokens. So vector embeddings basically is just converting natural language into a numeric representation that retains the meaning of that natural language. Okay, we'll look at vector embeddings maybe in the upcoming videos. But yeah, basically to convert natural language into numeric representation takes a bunch of compute, and you pay for these compute services from model providers like OpenAI, Anthropic, and other model providers. They're also free source, but yeah. So that is time consuming and it's expensive, because even if you're running the open source one, you still have to pay for the compute, right? Okay, and so another thing is that it costs more money for infrastructure, and the reason being because you need to store your vector embeddings in somewhere called a vector store. right? So if you convert those vector embeddings into numeric representations, we store them in a special database that we call a vector database or a vector store. So you need to go ahead and pay for these vector databases from different providers, or you can self-host them. One of these vector databases, for those of you who are curious, or you want to look into what a vector database is, you can check things like Quadrant, Pinecone, um, Malvis, and other providers. ChromaDB, yeah, those are some examples. So you can check those example of vector databases. Okay, so databases are used to store vector embeddings that are created from your embedding store. Yeah, so today I'm suffering from a bit of flu, so my apologies. So let's go now into prompt engineering first, RAG. So we have looked at prompt engineering and we have looked at RAG. So what's the difference between the two? So let's start with prompt engineering. So prompt engineering is just basically saying, you know what, in this use case of ours, let's just fit all the products information within the prompt as a context, right? In context learning, and that can lead to a bunch of issues as we've discussed. It's not only expensive, can lead to lost in the middle and poor responses. And then we have RAG, which is just like, you know what, instead of just fitting everything in, let's first search a database and retrieve only relevant information and pass only the relevant information as prompt into our LLM. In this way, we eliminate the issue of lost in the middle. We have shorter prompts, less cost, better responses, right? That's the way RAG is thinking. And then now let's move to another technique. Let's say that you have applied, John has applied RAG, he has applied fine tuning, he has applied, prompt engineering, which does not work very well. And then you applied RAG. RAG seems to work a bit well, but it's time consuming for some specific information. And also sometimes wrong information is being retrieved from the vector database, right? Why that wrong information can be retrieved is a whole another conversation. Okay. But basically, you can check out some of my previous videos on RAG system if you're interested in those. Yeah, so that's one of the challenges that RAG might face, is that sometimes wrong documents can be retrieved, can take a bit of time. It's not always perfect, right? It's not always sunshine and rainbow, right? As any AI systems. So another technique that you might use is say, okay, now John is like, okay, I think I can also try fine tuning. And one of the things I wouldn't suggest fine tuning in this specific case is that is dealing with product information. Product information can change, pricing can change, description of products can change, stuff like that. So fine tuning is not a proper approach. But let's say that John wants to fine tune on domain specific knowledge about Coded Prince LLP company, right? So he wants to fine tune on some specific domain knowledge which does not change direct. It stays constant for a long period of time, 10 years, 20 years before it changes. So in such a case, then fine tuning makes absolute sense. So let's take a look at what fine tuning basically is. So fine tuning basically involves taking a pre-trained model, like you have discussed all this in depth in the last video when you talk about introduction to LLM. So if you are interested in that, you can check the last video out. So what this simply does is that takes it takes a pre-trained model, right, which has been trained on a ton of data from the internet, takes this pre-trained model and train it again on some data which is domain data or in domain data in this case that they're using. This image I got it from Hugging Face. Thanks to the guys in Hugging Face. Yeah, so basically they're training this model again on in domain data. So the model is now far more fine-tuned to handle domain specific knowledge, right? And that's the whole idea of fine-tuning. Take a pre-trained model and then train this pre-trained model again on some data that you want it to be good at dealing with. In this case, John would take the data and take the pre-trained model and train it again on his domain specific knowledge about Code with Prince LLP, which is the company he works for, right? And that's the whole idea of fine tuning. And we talk about fine tuning more in depth in the last video, so you can check out that last video. And we have talked about different techniques such as supervised fine tuning or reinforcement learning from human feedback and all these other different techniques, right? So you can apply all these different techniques in these different approaches. So we can also apply things like prompting. They also have some prompting here, but in this case, you're focusing on fine tuning, right? Awesome. So why do we need to fine tune? So sometimes we need to fine tune to add new knowledge to an existing pre-trained model. We need some very domain specific knowledge. For example, formulas and calculations. Let's say that John is working for a stock market a company. Like those calculations don't really change. They have been there for decades and they have remained the same. So in this case, you can train them on such information. Custom LM response format that generate models that fine tune difficult to adhere to custom stuff like that. So customize LLM behavior, fine tune LLM to domain specific knowledge, deepen the domain expertise of these models. So some of these models we have been trained on data from the internet, right? So they have a bit of understanding about maybe all or most of the fields in the world that we have today because they've been trained on data from the internet, but they don't have that in-depth expertise. So in that case, you might want to enforce that in-depth expertise, and that's where you can go ahead and try to fine tune. So let's take a look at one of the real world applications of fine tuning, which is the case of DeepSeek R1. So if you've been probably around early this year when DeepSeek came out, or I think came out this year, yeah, 2025. Yeah, so DeepSeek came out and it was just like, wow, DeepSeek is this, and then it's gonna replace all American companies, and there was all this talk about it. Yeah, so how was this DeepSeek achieved? So DeepSeek was achieved through a process of taking Llama 4, which is from Meta, sorry, Llama 3.1, the 8 billion parameter model, and using a technique called distillation, which is a form of fine tuning. And then they got a new model. So basically, let me just have this diagram right here from Hugging Face. Yeah, so I got this image again from Hugging Face, and they show basically how the training of DeepSeek works. So they take a base model, in this case Llama 3.1, 8 billion parameter, whatever model that they have used, and then they go ahead and use reinforcement learning using high quality thinking data, and then they get a reasoning model or a reasoning LLM. Okay, so recently research came out from Apple saying that models don't actually really reason. Okay, that's the whole concept. I'm just giving you guys what's on ground. So yeah, that's basically, let's imagine that I didn't say that. So we have a reasoning LLM model, and we take a base model and then fine tune it using reinforcement learning, using high quality reasoning data, and then we get a reasoning model. So that's how we got about DeepSeek R1. Okay, so when in the other real world case might you use fine tuning? So you might be saying maybe you're trying to build a research, a medical document analysis agent. You're trying to do academic research summarization agent, where you take a bit of research papers and then teach basically this model on how to summarize. So you have a research paper and then you have example response, research paper, example response. So you create thousands of these rows of data and use it to train a model. You can also, when you say that you're building a chatbot for a company, which is in medicine or a medical chatbot. So in such a case, you need to fine tune it more on the medical documentation, right? So tune it more on what are symptoms, how to identify symptoms, how to diagnose and do hypotheses and those kind of things. Yeah, you need to fine tune it more on those kind of data. Or you're building a legal chatbot, right? You need to take maybe building a legal chatbot for let's say right now I'm currently in Nairobi, Kenya. So let's say that you're trying to build a chatbot for the Kenyan Constitution. So in this case, you need to go ahead and grab the Kenyan Constitution, generate a data set from that, and then use it to fine tune an existing model, right? Take a base LLM model and then fine tune it on this Kenyan Constitution so that it can answer questions that are very specific to the Kenyan Constitution, right? So in the real world on the internet, you have a bunch of data about the Kenyan Constitution. So we do for all other countries around the world, right? So the more the base models are not very specific or fine tuned to Kenyan law, so we need to go ahead and enforce them to pay attention more to Kenyan law, right? And focus more on Kenyan law and give them more context on Kenyan law. That's how we can do the fine tuning. If you're in the US, you use your constitution from the US. If you're in Madagascar, then you use your Madagascar constitution, right? So yeah, that's basically it. And yeah, so fine tuning versus retrieval augmented generation. So the whole idea of fine tuning is, you know what, let's update the weight parameters, right? And then such that we are much more faster to generate responses. And then let's take a RAG. So RAG is all about, let's retrieve the most relevant context and then pass it within our prompt. And fine tuning is about, you know what, let's actually train again this model from scratch so that it's much faster, much better, right, and less prone to errors. Okay, so should you combine RAG and fine tuning? From my point of view, I would say yes, you should combine RAG and fine tuning in some cases. Why am I saying this? So sometimes if it comes to RAG, right, RAG can retrieve the wrong documents most some of the time. So if it retrieves the wrong document, our model, bare model that you're using, should be aware enough that hey, we have retrieved wrong information. So it should use that domain, unchanging domain knowledge to figure that out, and then kind of generate a response that tells the user more accurate responses than going off of the wrong retrieved information from the RAG system, simply because it does not understand our domain knowledge and can't comprehend that the retrieved documents are wrong, right? So in such a case, you want a fallback. So to get a fallback, you fine tune the model because you're going to adjust the model itself. But RAG is only retrieving relevant, right, quote unquote relevant document, which might work sometimes, which might not work at times, right? So that's basically it. So sometimes you need to retrieve most relevant information, which RAG fails to do at times. So you need to have a kind of a fallback on, and that's where fine tuning can come in. So they are not like two opposing ideas; they can actually work together. In fact, all the things we've discussed from prompting, RAG, and fine tuning, all this can be applied into one system. Because even if you fine tune a model, you still need to prompt it in a way that you get the final output that you want, right? And sometimes if you fine tune a model, you have trained tuned it on information that does not change often. So you need to find, if you're working with information, a system that has information that's regularly changing, then you need to introduce a RAG system into that application, right? So you can see all these three are not opposing ideas. They actually work together in fine harmony to achieve a well-performing chatbot or AI system. Fine tuning, retrieval augmented generation, and prompt engineering. They're all working together. They collaborate together, right? But in this case, I've just explained how you start and how you can elevate the level of aggressiveness, if I can use that word, in terms of getting better responses, right? So things change. That's the whole idea I'm saying. And it's not like there is one shoe fits all or one size fits all. I don't know if that's a saying. Yeah, like I don't think it's that way of doing things like one size fits all. Let's just do fine tuning. All the other techniques are PS. We don't want to work with them. They are really horrible. Anyone that uses RAG is not skilled enough or doesn't have the experience. That's not it, right? So there are different ways of combining all these things together to work together in a unique harmony. So if you try one technique and it's not performing well, combine two techniques, it's not performing well, you can add a third techniques, and there are other techniques out there you can do, right? So one of the things I will urge you to look into is something that we call MCP. So basically a model context protocol, and it's kind of like the quote unquote replacement for RAG, right? Yeah, so that's all for this video, and I thank you guys for watching so much. I hope you found this content helpful, and if you do, one of the easiest you can support the channel is just by liking this video. Drop us a like, subscribe to YouTube channel to stay updated with all the upcoming videos within the course. And also, if you want to buy me coffee, you can use the link in the description below and to buy me coffee. Okay, so all this money is basically get invested back into the channel and doing other stuff outside, right? So you can connect with me on Medium, where I also have written articles about this video. Okay, so I have a written article about this video specifically, so you can see right here. So these are the written articles about this video. So yeah, so you can connect with me on Medium at Prince Cramper. You can connect with me on YouTube, hopefully you're watching this video, at Corporate Prince. You can also follow me on Twitter, aka X, at Prince_Cramper, or you can follow me on LinkedIn at Prince Cramper. So on LinkedIn, I'm much faster to respond to your questions and your inquiries. So if you have any suggestions, you have any project ideas, and you want me to help you build anything, you can always reach out to me on LinkedIn at Corporate Prince. So guys, thank you so much for watching this video, and I hope you found this video helpful and you have learned something from it. So thank you so much, and see you in the next one. Keep safe.